One thing we can say about lipids is that they're modular. And what I mean by that is shown by my little cartoon over here of triacylglycerols. Notice we've taken 3 pieces, fatty acids, and connected them to another piece, glycerol, by linkages that we called esters, or ester linkages. Later, we're going to learn that we can take these same type of pieces and put them together in different ways and create different molecules. So one of our goals here is to understand how these pieces and linkages are used to make something that has a particular purpose. In this case, it's a storage form of energy, all nonpolar. Now, in the last video, I also said that if we are putting together esters and making these esters, we show them over here as kind of fragile linkages because we can break them apart again. In fact, when we want to break down fats and oils from our diet, that's what we're going to do. We're going to break the fatty acids off and use them for energy. So this video is called Breaking Ester Linkages, and we're going to see how that happens on the next page. So breaking esters is shown here. Notice we have an ester in this form right there, COC double bond O. We saw that earlier. We can have any groups attached on either side. I'll just put R here and R here. And it's very important for us to understand not just how to recognize these, but to understand what they're going to look like when they break apart. Here's a little test for you. If I'm going to break this apart, let's say by adding a water back across that, which side, the left or the right, is going to be the alcohol and which side is going to be the carboxylic acid? That's an important skill. And let's pause for a moment and see what you come up with. So looking at this ester, I really want to see and have you see the asymmetry in it. Remember, there's an alcohol on one side and a carboxylic acid on the other. Let's do this little trick. Let's say we take that bridge oxygen, which is right here, and let's just wipe out one side. I know you probably can't do that, but I can do it on the screen here. I'm going to go and put an H on that. Well, now you can see it. We have the alcohol coming in from the left side. Now, let's get rid of that. Start over again here. Now let's go ahead and wipe out the other side and then go back and put an H on again. Well, now you can see that the right-hand side is a carboxylic acid. All right, well, that's a nice little exercise of how to do that. And let's finish it by pointing out that we would end up with an alcohol on the left and the carboxylic acid on the right. Very good. Okay. So this is the process of breaking esters. When we take a water and break it apart, we end up with what we had to begin with, which was an alcohol and a carboxylic acid. How do we do this? There's 2 ways that we can have this done. The first is called saponification. And I'm going to go ahead and put up here under the arrow what saponification requires. I'll do that in the same color. We'll call it NaOH and a little delta symbol, which means gentle heat. So if we take a base, strong base like sodium hydroxide, and a little heat, and mix it with some vegetable oil or something like that, we end up breaking the esters and creating the alcohol and the carboxylate. Now, I would point out, though, that in reality, what we're going to end up with is not the carboxylic acid, but it's going to be a carboxylate, because under basic conditions, or even under neutral conditions, that's going to lose its proton and ultimately become O-. So that's the real answer that we want, is an O-. Now, we also, by the way, end up with a sodium salt, Na+, that comes from the sodium hydroxide. So this is what we do in the lab if we want to break esters. And what about if you've got some bacon grease in your stomach from eating bacon or some peanut oil from French fries or something like that. We can't put sodium hydroxide in our intestine, so we're going to do something different. I'll do this in red. This is going to be done enzymatically. Enzymes. And the enzymes we use are lipases. And so we can say the second mode up here is enzyme. Doesn't require anything strong pH or anything like that. It's just neutral pH and 37 degrees Celsius. So that's our second mode. The first was up here, saponification. So these are the two different ways we can do it. The second way is how we do it in our body, and it's really important. You're going to hear about lipases in other classes. And the first way is how we do it in the chemistry lab with sodium hydroxide. Okay, that's the end of this video. We're going to have some homework to follow up on this where you look at esters and break them and try to figure out where the alcohol and where the carboxylate are.